Any formulation chemist knows the sting of this exact moment. You found a promising PFAS alternative in the lab, but the minute you scale it up, the fluid breaks apart and beads up on the substrate, a complete wetting and leveling failure. Removing PFAS from a product is an advanced matrix engineering challenge. It is impossible to solve through simple procurement substitution. Formulators routinely fall into the drop-in fallacy, hunting for a single fluorine-free molecule to replace a complex fluoropolymer. But deleting that ingredient triggers an immediate cascading collapse across multiple metrics. Wetting, leveling, oil resistance, and durability all crash simultaneously. Rebuilding that performance requires a rigorous 4-step reformulation architecture.
OnlyTRAININGS. Learn what works in the industry.
You have to move systematically through screening, deconstruction, engineering, and final qualification. Navigating this specific architecture is the core focus of the OnlyTRAININGS PFAS-Free Reformulation program on alternatives and testing. To achieve actual qualified performance without PFAS, development teams have to abandon the search for a magic bullet and instead build a targeted multi-component replacement system from the ground up. Let's look at stage 1 of this schematic: screening. No actual formulation work can begin until you verify the exact source and scope of the fluorine currently in your matrix. This requires proper total fluorine screening. You have to actively hunt down the undeclared fluorinated processing aids and contaminated raw materials that your suppliers might not even know they are sending you. Methodology matters. Targeted PFAS testing looks only for known compounds, often returning a clean result. But total fluorine analysis reveals a massive area under the curve. Mistaking natural, inorganic fluorine for unregulated PFAS entry points leads to false conclusions, misdirecting your R&D efforts. A robust fluorine screening strategy has to aggressively probe the entire supply chain, locating hidden entry points far beyond the bounds of your declared ingredients list. Without an accurate, verified baseline of all unexplained fluorine in your system, any reformulation effort is effectively flying blind, risking millions in wasted development hours. Once located, we move to stage 2, deconstruction. Before replacing the chemistry, you must understand exactly what that fluorinated material was doing in the physical environment. A single PFAS molecule is a multifunctional anchor, dictating dynamic surface tension, anti-cratering, water repellency, oil barrier, and slip simultaneously. To engineer a replacement, you must break that anchor, isolating primary required functions from secondary ones, leaving specific functional voids to fill. The formulation team must then prioritize these voids based strictly on the end-use application parameters and the specific viscosity requirements of the matrix. By mathematically separating the primary functions from the hidden ones, you stop trying to replace a complex polymer with a single molecule and start building a deliberate functional architecture. That architecture comes to life in stage 3. Here, the theoretical functional map is populated with actual alternative chemistries. This scorecard illustrates alternative technology platforms across major sectors. This stage requires building multi-component replacement packages. When looking specifically at coatings, silicone and hydrocarbon-based surfactants face strict physical limitations, forcing specific trade-offs to match original anti-cratering performance. Formulators must also carefully balance the trade-offs between chemical durability and thermal resistance when engineering alternative packages for high-stress adhesives. For packaging barrier developers, the challenge shifts to thermodynamics, specifically matching extreme oil and grease repellency without fluorinated systems, which naturally repel both water and oil. In textiles and leather treatments, maintaining durability and stain resistance across wash cycles requires distinct matrix adjustments rather than just simple surface application of alternative waxes or nanomaterials. Rebuilding the precise release, slip, and low friction properties previously provided by PFAS in lubricants and industrial fluids demands an entirely different set of tribological replacements. And in cosmetics and personal care, the engineering focuses on matching highly specific sensory profiles and leveling characteristics without compromising formulation stability. Ultimately, successful multi-component engineering requires mastering chemical antagonism. You have to ensure that the 3 new functional ingredients you add don't interact, precipitate, and destroy the baseline stability of your entire matrix. But aggressive performance engineering often creates a massive regulatory and toxicological blind spot. This is the trap of regrettable substitution. The error of successfully replacing a regulated PFAS with a new alternative chemistry, only to discover your replacement possesses a similarly hazardous or highly persistent environmental exposure profile. To avoid this, teams must integrate strict hazard and exposure screening concurrently with their physical testing. It cannot be treated as an afterthought in the development cycle. Your alternative platform's technical performance is entirely irrelevant if the chemistry you select triggers a compliance failure under incoming European Union mandates or imminent EPA restrictions. This brings us to the final stage of the workflow, ensuring your newly engineered matrix can actually survive the realities of commercial production. This chart shows what a robust qualification program looks like. Laboratory scale success means very little on its own. You must track the formulation's performance as it holds steady against accelerated aging, matrix degradation, and high shear production variability. Qualification also mandates targeted testing on the finished scaled product to guarantee processing equipment hasn't reintroduced fluorine. Finally, you must establish airtight supplier evidence. Passing matrix stability requires chemical traceability back to raw materials to verify supplier controls. This exhaustive qualification protocol is the only reliable way to protect a brand from litigation and ensure final state compliance in the market. Executing this exact step-by-step methodology results in rock-solid PFAS-free product claim substantiation. It eliminates risks of accidental greenwashing or overclaiming your product's regulatory status. Stop searching for a non-existent drop-in replacement. Start mastering this engineering workflow by enrolling in our PFAS alternatives and replacement training. Visit OnlyTRAININGS to access these advanced, expert-led sessions. They're designed specifically to help senior R&D and analytical teams build a technically defensible pathway from fluorine detection to qualified PFAS-free performance.